and I will enable OSPF. Then I will capture the link between routers, and after that we will see the packet. Hello message will carry what informations? Any five information? And one more thing, hello parameter, oh sorry, neighborship parameter. What are the parameter of neighborship?
Like router ID should
Router
be
ID.
unique, area
Router
ID
ID
should be
should be
same,
unique, area ID should be same,
subnet should be same, and
subnet mask should be same,
hello and date timer should be same,
hello and date time should be same. Very good.
authentication
MTU
is
should be
applied,
same.
MTU should be same.
and authentication is applied, then that is also should be same, and this
Authentication type and authentication data should be same. Okay,
yes,
Priority.
and the flag stub flag. So if it is stub network, then that is also
correct,
should be same.
correct, correct. Okay, fine. Now, first let me configure IP on these two router. First, we are discussing practical of last video, and then I will discuss again. I will start from router LSA, LSA1.
Sir, kindly start the recording.
Recording is started, brother.
Okay, okay.
आज क्लास से पहले ही कर दिया.
अच्छा. एक्चुअली बाद में बहुत ज़्यादा ज़रूरत पड़ता है.
श्योर श्योर, समझ सकता हूँ. मैं भी जब सीखता था तो वैसे ही होता था. Okay.
Yes, sir.
Now on fast Ethernet 0/0 of router 1, I am going to configure IP address 12.1.1.1 255.255.255.0. Guys, to enable OSPF on interfaces, we have two options. One in router OSPF mode and one in interface mode. On interface basis also we can enable OSPF. Okay, so we have two options to configure or enable OSPF on the interface. Okay, now on router number 2, first let me configure IP address 12.1.1.2 255.255.255.0 no set and exit. I have configured the IP address on both router. Now here I am running command router OSPF process ID. Process ID range is, you can see, it is 16 bits value. It is 16 bits value we can use from 1 to 65535 in this range. And process ID is locally significant. We can configure same also on two router, or in we can configure different also. Right, this is not in OSPF neighborship parameter. So here let's say I am configuring OSPF process 1. This is, you know why, because we can run multiple OSPF process on a single router. So to identify the process, we have process ID. Router OSPF process 1. See this message. Why? Here I think I have configured the IP address. Still router is not able to allocate unique router ID. I think we need to run no set command on this interface, or manually we can say router ID 1.1.1.1. Okay, now when I will run this command network 12.1.1.1 wildcard mask 0.0.0 and then area 0, that means I am advertising this interface in which area? In area 0. Now once I will hit enter, first of all this interface will join one multicast group. Which multicast group?
Dot 5.
Dot 5. Each router will, as you know, OSPF is using two types of multicast address, dot 5 and dot 6. But all router in OSPF domain will join dot 5, and dot 6 will be joined by two a special type of router, that is DR and BDR. We will discuss in upcoming time. But for now, all the router, all the OSPF enabled interface will join 224.0.0.5 multicast group. Okay, after that it will start sending hello message from this interface, and in this hello message it will not add neighbor router ID, because till now router don't have any neighbor. Router 1 not received any hello message from their neighbor. So hit enter, and now in capturing, I can show you the hello message. It is the layer 3 protocol. So at network layer, OSPF will generate one hello message. After that, hello, it will encapsulate hello message with IP packet, IP header. Then it will hand over to lower layer, exactly like EIGRP. So wait. So IP interface brief exclude unassign. Fast Ethernet 0/0 is still down. Okay, let me run no set command. Interface fast Ethernet 0/0 say no set. That's it. Now we will see hello message of OSPF here on this interface. Gracious are then OSPF hello packet. Source IP is IP address of exit interface, that is 12.1.1.1, and destination IP is 224.0.0.5. Multicast address of OSPF. Now if I will open this hello message, see there are two important information inside the hello message. This is OSPF hello message. In IP header you can see source IP is this one, destination IP is this one, and inside the hello packet there are two important information. One is OSPF header and one is OSPF hello packet, right? This each LSAs will have one header. Inside the header there will be some information, and inside the actual hello packet there will be some information. In LSA1 you will see this header. Header will carry version information, types of message information, packet length. Okay Prem, 44 byte packet length of hello message. Yesterday I think you were asking length information. Then source router ID 1.1.1 is the router ID of router 1. Area ID 0.0.0.0. OSPF represent area in IPv4 format, like we have configured here area 0. So it will represent area 0 like this. Area 0 it will represent like this. If I will define area 1, it will represent like 0.0.1. If I will define area 256, it will represent 0.0.1.0. Getting my point? Okay. So area ID representation is in IPv4 format. Fine. If we are defining area 255, it will represent like this. How it will represent area 255? Hello.
0.255.
0.255. Correct. Okay. And if we will configure 256, then 0.0.1.0. 1.0 or 1.255? 1.0 or 1.255?
1.0.
1.0.
1.0.
Okay, so this is similar, like we discussed these things in subnetting. Exactly. Area ID, after that there is checksum. Authentication type is, you can say, null. Authentication data is nothing. These are information inside header. This is header of hello message, right? All LSA will, like LSA1 will also have one header. Like if I will show you R1 database, so IP OSPF database. Inside the database there is one LSA1, LSA1 of router 1. If I will open this LSA1 in detail, so IP OSPF database and router LSA 1.1.1.1, you can see in this is header of LSA. This is, why my mouse is, this is header of LSA, and this is actual information of link. Actual information of link. Fine. Now it's saying link connected to A stub network. Router 1 is thinking that this is a stub network. A stub network means like your LAN network. Fine. So, okay, after that, if I will open this field, OSPF hello packet. So inside OSPF hello packet, there is information of subnet mask, that should be match. Hello time, that should be match. Priority is there. We will discuss about priority also later. On fast Ethernet link, by default OSPF calculate priority 1. Then date interval time, then DR router, BDR router. We will discuss about DR router, BDR router later. But for now, router 1, for router 1, DR is unknown, BDR is also unknown. 0.0.0.0 means unknown. But if you will check latest message like here, so IP OSPF, sorry, so IP OSPF database, or we can do one thing, so IP OSPF interface fast Ethernet 0/0. Now a state of this interface is network type is okay, broadcast cost is 1, process ID is this one, and state is DR. Now this router is DR. So if you will check latest message, latest hello message, you will see DR router ID will be 1.1.1.1, router ID of router 1. But this is first hello message, so DR router is unknown because there is some timer of DR and BDR election. So first router will wait for that timer. If router will not receive any hello message with higher router ID within that timer, router will declare their self as DR. So that's happened in this scenario. Router 1 have not received any hello message with higher router ID, so router 1 have declared their self as DR. But in this hello message, we are able to see designated router ID is 0.0.0. Now let me open any latest hello message, this hello message. Inside this hello message, you can see DR router ID is 12.1.1.1 and BDR is still unknown. Fine. So we will discuss about DR, BDR. This is hello message. Fine. Inside the hello message, we can check header information. Inside the header, there are some information like router ID, that should be unique, area ID, that should be match, right? And area 0 is backbone area. We will see in upcoming day this also. And after that, authentication. So authentication is not configured here. And then inside the OSPF hello message, there is subnet mask, hello timer, priority, DR, sorry, date time, DR, BDR, and this thing. Fine. Now see, only router 1 is sending hello message, but router 1 is not receiving any hello message on this interface. So a state of R1, a state of this interface of R1 is now down. Now I am going to configure OSPF on router number 2 also. Like let me here configure OSPF router, OSPF process 1 and router ID 2.2.2.2 and then network 12.1.1.2 0.0.0. This is IP address of fast Ethernet 0/0 of router 2. Then area, in which area you want to advertise this interface or this network. So I want to advertise it in area 0. Now in the capturing, you can see, okay, don't see these messages first. Okay, see, first router 2 have sent one hello message. This is first hello message of router 2. Fine. First hello message of router 2. Source is 12.1.1.2. Destination is 255. Again same multicast address 224.0.0.5. And in this hello message, if I will open this hello message, you can see we are not able to see neighbor information like neighbor router ID. But in the second hello message of router 2, where is second hello message of router 2? This one. If you will open this message, you can see there is information about neighbor router ID also. Active neighbor is 1.1.1. Now inside the hello message of router 1, there is router 2, there is information about active neighbor also, that who is active neighbor of router 2. See, in this hello message, source is 12.2, means router 2 is sending this hello message to 12.1. This is unicast message. not multicast message. This is second hello message, and inside this hello message there is information of neighbor router ID also. So on's router will receive, router 1 will receive this hello message. It will find their on router ID inside the hello message. State will move from init to two way. First router will receive this hello, router 1 will receive this hello message, right, from of router 2. Inside this hello message there is no information of neighbor router ID. So a state will be still in init state, because it have received the hello message but it have not found their own router ID. But in this hello message, second hello message, we are able to see neighbor router ID also. Okay, and then state will here in two-way state, dr bdr election will happen. One router will become dr here, right? Router whose router ID is higher, that router will become dr. So in this scenario, which router will become dr, guys?
Router 2.
Router 2. But what I said that whenever we will enable OSPF on interface, router will wait for a specific interval for dr and bdr election, correct? On this segment, definitely one router will become dr, but when I have enable OSPF on router number 1, router 1 have wait for 40 seconds for the dr and bdr election, right? But within 40 seconds, router 1 have not received any hello message with higher router ID. That's why router 1 have declared their self as dr. So now once one router will become dr in this segment, router 2 cannot become now dr, because dr is already there. So router 2 will become what? BDR, backup designated router. Still router 2 have higher router ID, router 1 is dr router. So how we can verify? So IP OSPF neighbor, you can see 1.1.1 is dr router, or you can check detailed OSPF configuration on fast ethernet 0/0 by running command show IP OSPF interface fast ethernet 0/0. So you can see here this router is BDR, backup designated router. When